Hello friends, I am Santosh Bhopre. Again, we will start with the second lecture of this particular series of the optical fiber. In the first lecture, we have discussed about the what is optical fiber, what is WDM, what type of generations are there, first generation and second generation of the optical fiber. Then we have discussed about the architecture of the optical fiber, and after that we have started with the discussion on the components of this optical fiber. Out of that we have just discussed about the optical spectrum in the previous one, and some of the components like optical diode and all that things we have discussed. In this lecture we are going to start with this optical fiber construction. So here in this optical fiber, it is made up of three sections. One is core, second one is clad, and third one is the coating. Here you can see this is the core which carries the light signal from one place to another place. We can say source, from the source to the destination, and the cladding keeps this light in the core only. So this is the preventive material which prevents the light to be in the core and not going outside that particular core, so that we can say whatever we want to transfer, it is inside that particular core. And the third part, or the third section, is nothing but a coating, which is for the protection of this particular glass as well as the cladding. Here we can say this is the overall structure. From this source, when we are sending some light source or light as a signal, this particular passes through this core, and this is the clad, and at the destination we are getting the signal as a received signal. In the fiber construction, we are having some this looks like this particular, it is having the outer jacket. This is the outer jacket, we can say the cover of this particular cable. Then this is plastic buffer we are having here. These are some of the threads for the strings, and this is the cladding in which we are having some glass or plastic core, so that we can transfer the signal. And this particular construction gives us the loss free or the attenuation free transmission from one end to another end, and it is also providing us the ability to transfer the signal at the higher distances or for the long haul distances. Then the next part, when we are having any optical fiber cable, we are dealing with the connections. So here also we are having some connectors. The optical fiber connectors are of three types. The first one is the SC type connector, where the subscriber can be connected through this particular, so it is having the name like subscriber connector. Second one is ST connector. Here the straight tip connectors are there. These can be used in between the wire, so that we can connect the straight tip together. One is third one is the MTRJ connector, where it is mechanical transfer registered jack. It is having some different kind of operation, so you can go through this particular afterwards. Then the next part of this optical network is about the propagation mode. How we are transferring the signal from one end to another end, or what type of mechanism, what type of mode we are going to use for the fiber optic transmission. The modes are of two type. One is single mode and second one is multi-mode. In the multi-mode, we are again having the two types, that is step index and the gradient index. Here you can say this is the single mode, where the source is sent, or the source signal is sending through this particular core. Here we are having only one signal. So whatever the signal, whatever the single signal as a light source we are sending, it is received at the destination, so it is having some less attenuation here. But in the multi mode, if you are just gone through this one, the first a figure gives you the source, whatever we are sending as a square wave here in the light form, that can be transferred through this particular optical fiber cable in the multi mode. Means here the three signals are sent at a time, and these signals are having some refraction over this particular glass surface inside. So these angles are very important. Here the theta, what we are calling it as theta, theta gives us the signal strength. Whatever the signal we are getting at this particular end, it is depending on the how many times this particular signal uh, refracted through this particular glass surface, and this particular signal, in between signal, is again same as this particular single mode. So whatever the strength we are getting, that is somewhat less at the destination. In the second multimode graded index, we are having some graded index where we are sending the signal in the form of sinusoidal wave, or not directly we can say it is sinusoidal wave, but it is not having a sharp angles of the 45 degree or 50 degree. So it is having some angle which is more than that, and we can say it is a smooth signal, so that the loss or the attenuation is less in this case as compared to previous step index. And single mode is very efficient because here the grading or even the angles are not made, only one signal is sent at a time, so it is providing less attenuated signal at the destination. One more component is very essential in this particular transmission of the optical fiber, that is an optical amplifier, which is a device that amplifies an optical signal directly without the need to first convert it into an electrical signal. Means whatever we are transferring, we are going to amplify. When we are thinking about the long haul distance, we have to amplify the signal again and again, so that the strength of the signal remains as it is, and at the end of receiver we are getting the good quality signal. So here it is not like that one, that it is an amplifier which is amplifying the optical signal only. There is no need to convert the opto signal to the electrical, and electrical signal again to the opto. It is like a opto amplifier, so it is only taking up the optical signal and amplify it, and once again it is sending. So here it is not like a regenerator. Previously we can say when we are converting that particular to electrical, again it is amplifying, and again it is converting to the optical. Means what we are doing, we are regenerating the signal. So it is not a regenerator. When fiber amplifiers we are considering, these amplifiers are having the optical amplification capacity. An optical amplifier may be thought of as a laser without an optical cavity, or one in which feedback from the cavity is suppressed. So here the feedback from the cavity is suppressed and sent to the next one. Here one amplifier is taken as example, erbium doped fiber amplifier, EDFA. It is an amplifier which consists of a length of silica fiber whose core is doped with ionized atoms or ions Er3+ of the rare earth element erbium. This fiber is pumped using a pump signal from a laser, typically at a wavelength of 980 nanometer to 1480 nanometer. So here this particular pump is used at this 980 nanometer. So here we are using at this particular end, or at this particular end we are using the couplers. These are the components which are used for the coupling purpose at the fiber optic. And here the erbium fiber is used for this particular purpose of the amplification. In order to combine the output of the pump laser with the input signal, the doped fiber is processed by a wavelength selective couplers. Here these particular couplers are used. At the output, another wavelength selective pump, or the residual pump we can say, is coupled, and which is needed to separate the amplified signal from any remaining pump signal. So this particular residual pump is uh, used to separate an amplified signal from the remaining signal. Usually this particular isolator is used at the input or output of an amplifier to prevent reflections. So this particular is used for the prevention of the reflection into the amplifier. Here the several factors has made this particular EDFA as the amplifier of the choice of the today's communication system, because the availability of the compact and reliable high power semiconductor pump is this one, and the fact that it is an all fiber device, making its polarization independent and easy to couple light in and out of it. So it is very easy to in and out the light from this particular fiber. The simplicity is there in this particular device, or EDFA. The crosstalk is less. We can say here in this particular the crosstalk is less, or it is nearly zero. Okay, so this is the one of the amplifier which we can use in this particular type of mechanism or in the fiber optic cables.